And we're going to talk about redox, oxidation and reduction in electrochemical cells in this section. So there's some little animals on the earth can make their own energy, and they can turn energy into light, and so they're doing redox reactions. So especially the ones way deep in the ocean, they make little lights to attract other things towards them so that they can eat them. So in electrochemical process, we're going to have two metals. One likes to be oxidized and one wants to be reduced. And we're going to have a chemical reaction called a redox reaction in electrochemical processes. So for every two metals that you're going to use in this process, you're going to have one that's more active and is more easily oxidized. So in this situation, zinc wants to be oxidized and copper wants to be reduced. So oxidation is when you're starting with a charge of 0. You're losing 2 electrons, and then zinc becomes a +2 because it lost 2 negatives. Copper is going to do the opposite. Copper is going to want to copper ion is going to want to grab 2 electrons and become copper solid, 0 charge. So this reaction happens spontaneously because zinc wants to become oxidized. So if we show this situation, we put zinc metal in a solution of copper 2. This blue solution has copper ions with a +2 charge. Zinc is automatically, spontaneously going to want to change from zinc into +2 and give 2 electrons to that copper, which is then going to settle there as a copper metal. And over time, you're going to have this copper metal plating out on top of this zinc bar. So copper is going to make a layer like that. So lots of jewelry and different metals are electroplated. If you've heard of that word, the metal is deposited on top of here by using an electrochemical process. So we have that copper solid at the outside. This black looking stuff is the copper settling on the outside of the zinc. So that's an electroplating process. So if you look at this chart, zinc is higher up than copper on the chart, so zinc is going to want to do this process. It's going to want to change from solid into 2+ charge much more readily than copper wants to do that. So zinc is going to be the one who oxidizes, and copper is the one who wants to be reduced. That's called an activity series. So that activity series helps you with that. So all electrochemical processes are redox reactions. Somebody's oxidized, somebody's reduced. And we can use this to convert back and forth between chemical and electrical energy. And so we're going to talk about electrochemical cells in this section. So a voltaic cell produces electrical energy by having a spontaneous redox reaction like I just showed you. And they're named after Volta, who figured it out. And he was able to make a cell called a voltaic cell. We named it after him. So a half cell is one part of that cell where either oxidation or reduction is happening. And between those two half cells, we have to allow electrons to move. So it's generally potassium sulfate that we put into a tube, and it's in water, so that it's called a salt bridge. So electrons can flow through it, just like we have electrons flowing through wires to power our lights and our computers and things like that. Same thing with a salt bridge. It's kind of like a wire. Electrode is a conductor in a circuit that carries the electrons to or from a substance. We have anodes that can be an electrode, and we have cathodes that are a type of electrode. So anodes are where we have oxidation, and cathodes are where we're having reduction. And Volta is the one who first started this. So I don't know if you've ever tried a little experiment. You might have done this in science, where you take like pennies and nickels and you stack them on top of each other, alternating, and then you between each one you put like a salty piece of paper towel. It's really fun, and you're able to make your own battery this way. So that's what he did. He was the first one who figured this out. He had 2 different metals, silver and zinc, and he put them alternating, and he put wet material, cardboard in between, that was soaked in salt water, and it was able to make an electrical current. So here's the first one who made a battery. And this is how it works. We have the zinc changing, giving up electrons, and then the copper is accepting the electrons. So this is the half cell. This is called another half cell reaction. And then you can put these together and not show the electrons, and this is what's happening. So this is really showing exactly what's happening with electrons up top here. And this is the overall redox reaction. So we have the two different metals, and we have the salt bridge in between, and we are able to produce an electric light from that current. So on the left side we have an anode, and on the right side we have a cathode. Anode has a negative charge, cathode has positive. That's why you see these little symbols on a battery. And on this side, we'll talk about the anode first. We have the zinc metal wanting to let electrons go, and then it becomes zinc. It jumps off of the metal plate here and goes into the solution as Zn2+ ion. And those electrons start traveling through that wire. And also we have that sulfate I was talking about. That has to go there to balance out these electrons moving out. So if negatives are going that way, we have to have the sulfate come out here to balance out that negative charge moving. So here's what's happening on an atom level. We have zinc metal is changing from zinc 0 to zinc 2+, and it's giving up electrons. They're coming up through that wire right here. And let's move on to the cathode. We've got the cathode here, which is letting electrons come into it because the electrons are coming from that anode and from that zinc. So the cathode, we have copper metal, and the electrons are traveling from the anode over here, and the electrons are jumping, the copper is accepting those electrons, becoming, the electrons are coming into these CO2+ ions and forming the copper solid. So this metal plate is going to become bigger with more copper on it, and the zinc on the other side is going to be depleted in the zinc. And you also have sulfate, the potassium sulfate in the salt bridge, and the potassium is going to want to go this direction to balance out negative charges coming in here. We have to have the charges balanced. So this whole salt bridge is to balance out charges. If you don't have the salt bridge, you can't have this circuit. And what's happening here is we have Cu2+ in the solution. We put the copper 2+ in the solution, and it grabs the electrons and then starts attaching itself to more copper on this bar of copper. So you have Cu2+ adding 2 electrons that came from the zinc and forming solid copper on this bar. And the sulfates move in that direction to make everything balance out. So this is how you can represent it. This is the shorthand way of showing that you have zinc solid and copper solid electrodes, and then you also have this in solution. So what do we use these for? We use voltaic cells to make electricity, and you use these in all the things that require batteries and in your car. And so this is what's happening in a dry cell. And instead of having electrolyte as a liquid, we have it as paste. So it's still the same idea as that salt bridge. We need some kind of paste in there for it to work. And so we've got a graphite rod is the cathode in a dry cell. And then we have the paste to allow things to move, and then we have a zinc anode. So that's a dry cell, and then an alkaline battery has the graphite as the cathode, and then zinc is an anode, and then you have a paste in the center to allow the electrons to move. So you have a circuit. So here's the way a lead storage battery works. So that's the formula for that. And we use a lead storage battery in your car, and it allows a lot of things to happen. So we can have an oxidation reaction from our lead storage battery. We're going to let electrons discharge and come back into the battery. So we're going to allow discharge to happen in your car, and then we also allow recharge of your battery to occur in your car as well. So we have two things going on. And fuel cells are being researched now. So we're trying to think, hey, can we use this in a car and make make a more environmentally friendly car? So fuel cells are being researched now, and they're used in our space program because it's a nice clean source of power. So that's about electrochemical cells. Let's see how well you do on your quiz. So check this. See what you think. So that's the answer for that one. So we have electron transfers. What's the name for electron transfers? Good job. So spontaneous and they're redox. So portable sources of electricity use voltaic cells, and they are called batteries. Good. And then in automobile storage batteries, sulfuric acid is used as, what do you think we use that for? Good. We need to have electrons moving, and charges have to be balanced, so that's the electrolyte. We use sulfuric acid in battery. And then last, fuel cells, what is going to happen? Very good. We're going to form water. Good job. So that's the beginnings of redox, and we'll talk more about it. I hope to see you soon. Bye-bye.